A 28-ton metal monster built from a farm tractor, a military establishment that tried to destroy it, and a bizarre mathematical shape that changed human warfare forever. The first tank didn't just break the trenches of World War I, it barely survived its own creators. France, 1916. You are pinned in a trench. 50 yards away, German Maxim machine guns wait in the mud. The air tastes like cordite, copper, and wet earth.
Stand up, you die. Stay, and the artillery buries you alive. The generals have no strategy left except feeding more human flesh into the meat grinder. Humanity has engineered a perfect, inescapable stalemate. How do you build a machine to cheat death when the laws of physics and your own generals want you to fail? Subscribe to Method and Myth as we deconstruct the geometry of war.
The Western Front was a 400-mile scar of death stretching from the Swiss border to the North Sea. By 1916, the war of movement was over. Both sides had dug into the earth. The defense had completely outpaced the offense.
In the first 24 hours of the Battle of the Somme, the British Army suffered 57,470 casualties. Let that number sink in. 57,000 men wiped out for a few miles of useless dirt. Cavalry charges were slaughtered in minutes. Traditional infantry assaults were shredded.
The tactical problem was agonizingly simple, but mechanically impossible. How do you transport men across 500 meters of craters, thick barbed wire, and relentless lead? You need armor, but armor comes with a devastating penalty: weight.
Put thick steel plates on a conventional truck and you create a coffin. The standard rubber tires sink instantly into the bottomless French mud. The vehicle gets stuck, becomes a stationary target, and gets blown to pieces by artillery. They needed a vehicle that didn't just resist bullets, it had to rewrite the laws of ground pressure. Enter Ernest Swinton. He wasn't a legendary frontline hero. He was a British Army officer and a desperate man, terrified by the industrial slaughter he was witnessing. In 1914, Swinton saw something that sparked a revolution. He watched an American Holt Caterpillar tractor pulling heavy artillery through the thickest mud in France. It didn't have wheels, it had continuous tracks. He had a revelation. What if you armor the tractor, mount naval guns on it, and send it straight into the Maxim machine guns?
He took his proposal to the military high command. They hated it. Lord Kitchener, the Secretary of State for War, dismissed the concept entirely, calling it a pretty mechanical toy. The military bureaucracy, obsessed with horses and traditional warfare, nearly suffocated the project before a single prototype was built.
But Swinton refused to let the idea die. He bypassed the army entirely and found an unexpected ally in the Navy, Winston Churchill. Churchill, then First Lord of the Admiralty, instantly saw the potential. He secretly funded the Land Ships Committee using naval budget money, hiding it from the army generals.
Secrecy was paramount. To keep German intelligence completely in the dark during the manufacturing phase, factory workers were fed a bizarre lie. They were told they were building mobile water receptacles for the Russian army. They gave the project a deliberately boring, unassuming codename. They called it a tank. Naming it was the easy part. Building it required brutal engineering compromises. William Triton and Walter Wilson were the engineers tasked with making Swinton's landship a reality. Their first enemy was ground pressure. A wheeled vehicle focuses all its weight on 4 tiny points of contact. Think of a woman walking in deep snow wearing a stiletto heel. All her weight is focused on one point, and she sinks instantly. But Caterpillar trucks spread the weight over a massive surface area. It acts like a snowshoe, allowing a massive 28-ton monster to literally float over the mud. So the tracks solved the mud, but then they ran into a geometry problem. To cross a standard 9-foot wide German trench without falling in, the tracks had to be incredibly long. However, to climb out of a crater or overcome a 4-foot vertical dirt wall, the front of the tracks had to be angled sharply upwards. You couldn't just put tracks under a rectangular box. The solution was the iconic rhomboid shape. the tracks wrapped entirely around a diamond-shaped hull. It wasn't designed to look terrifying. It was the exact mathematical shape required by the battlefield. Form strictly followed function. But inside the beast, it was a nightmare. The Mark I had no steering wheel. It required 4 men just to execute a simple turn: a driver, a commander operating the brakes, and 2 gearsmen wrestling with massive secondary gears. All this happening in 120-degree heat, deafening engine noise, and choking carbon monoxide fumes.
And it almost failed completely. During a critical trial at Hatfield Park in early 1916, an early prototype known as Little Willie tried to cross a simulated trench. On a mild turn, it simply shed its heavy metal tracks. The tracks popped off the rollers. If the engineers couldn't fix the track tension, the War Office would have scrapped the entire program that afternoon. Tritton and Wilson worked frantically, redesigning the track plates and the suspension system just in time to save the landship from being canceled. History tells a convenient myth. The tank arrived, terrified the Germans, and World War I was instantly won. The truth is much darker. The debut of the tank was a disaster. On September 15, 1916, tanks were deployed for the first time at the Battle of the Somme. It was a catastrophic tactical failure. The generals, still not understanding the weapon, deployed them in small, isolated groups of 2 or 3. The early Daimler engines overheated almost immediately. Most tanks broke down mechanically before ever seeing the enemy. Others sank into deep swamps because the intelligence on the terrain was wrong. They were easy targets for German artillery. The infantry couldn't keep up with them, and the tanks couldn't hold ground alone. It took the military more than a year to realize the tank wasn't a defensive shield or a slow infantry support tool. It was a battering ram. You don't use a battering ram with one finger. At the Battle of Cambrai on November 20, 1917, everything changed. They didn't send 20 tanks. They sent 476. They chose solid, uncratered chalk ground instead of bottomless mud. The massed armor rolled forward like a mechanical tidal wave, crushing the barbed wire and breaking the impenetrable Hindenburg Line in mere hours. Tactics, finally, had caught up to the engineering. The Mark I was slow, moving at a walking pace of 4 miles per hour. It was blind, deafening, and highly unreliable. But the DNA of that desperate, bizarrely shaped machine changed the calculus of war permanently. That impossible equation, balancing firepower, mobility, and armor protection, is the exact same engineering challenge solved today inside every M1 Abrams and Leopard 2 main battle tank. The tank didn't just break the trench lines of Europe. It paved the mechanized road to every modern war fought since. And next, we decode the invisible web that now commands the skies above them: radar.